All right, well, good morning, good afternoon, good evening again. We are talking about scientific notation. It's going to be the 5.4D. We're going to talk about multiplying and dividing numbers in scientific notation. So again, what are we going to do for scientific notation? Well, here's scientific notation. Our scientific notation is going to be A times 10 to the nth power. Definition of A just has to be between 1, could be equal to 1, and cannot be equal to 10. If it's 10, it goes to the next level. And you know what? That one there is going to be really important today when we're talking about multiplying and dividing um, numbers in scientific notation. So let's go here. We're going to go past things we've seen already, and we're going to go here to talk about multiplying and dividing numbers in scientific notation. Here's just a reminder as well. What is scientific notation? Scientific notation is a number in the form A times 10 to the nth power. So there's our scientific notation. A has to be between, could be equal to 1, but it has to be less than 10. And now, so there's just kind of our definition, how we're going to use it. Let's look at multiplication. So again, all these steps here, if you're going to look at adding it to a cheat sheet, a study guide, something like that, that's helpful, but you got to keep in mind that I have to understand all three of these steps and kind of why we're doing them in order to really kind of do well, not only in this class, but also in Math 141, which is coming up next semester. All right, step number one is multiply the numbers, the number part of the two numbers, and that would be multiply the a's. So we're going to have two numbers in the form a times 10 to the nth power. We're going to have two numbers that have a parts of them, so multiply the a parts. And we're going to write that number down, and then we're going to multiply the times 10 to the nth power of both of the numbers, or maybe all the numbers that we have. In other words, add the exponents. And oh, by the way, remember b to the mth power times b to the nth power is b to the m plus n power. So if we've got the same base, in other words, the 10 to the nth power is going to be the number that we're multiplying down here in step number 2. 10 is our base, n is our exponent. If we go over here, 10 would be our base, and all we do when we multiply 10 to the 10th power times 10 to the 11th power is add the 10 and the 11 to get 21, 10 to the 21st power. So that would be, again, something to remember. Step number 3 is where we have to think, all right, well, if the product for number 1, where we multiply our a's, is above 10, or 10 or more, then we got to do something, because this a part in our multiplication has to be between 1 and 10. And if we multiply some things or divide some things and we get something that's outside this range, then we've got to kind of modify the number that we get. So let's take a look at what we need to do later on. Move the number to the left or the right and kind of modify the exponent as well. All right, so here's what we're going to do. Here's an example. We got 4 times 10 squared times 2 times 10 cubed. So here's a number here, 4 times 10 squared, that's a scientific notation number. 2 times 10 cubed, that's a number in scientific notation. We're going to multiply two numbers in scientific notation. So remember up here we said step number 1 is multiply the a parts. So I'm going to say, you know what, my first a part is 4, my second a part is 2, and I'm going to say, you know what, multiply those two together. 4 times 2, that gets me 8. Step number 2 was multiply the 10 to the nth powers. I'm going to say, well, my 10 squared is my first number from scientific notation, from the scientific notation number. My 10 cubed is the second 10 to the nth power. So we multiply these together and we say, well, 10 squared times 10 cubed is, remember, here's our base, 10 is our base, so 10 is our base. We're multiplying the same base, and we just add it when we're multiplying two numbers that have the same base, two exponents that have the same base, we just add the exponents. So in blue, when we multiply 4 times 2, we get 8. And that's, again, times the number in the exponent. Hang on just one second. I lost my page here. Isn't technology wonderful? All right. Let's go to green. All right, now I go to green. 10 squared times 10 cubed is, we got the same base, so we add the exponents. We get 10 to the 5th power. And there's our 10 to the nth power. So what's our answer? 8 times 10 to the 5th power, 8 times 10 to the 5th power. And you know what? Let's go back, just kind of out of curiosity, and say, well, what would happen if we kind of took a look at what these numbers are? 4 times 10 squared is 4. We write down the a part, and we move the decimal point 2 spots over, and I got 400. Times 2 times 10 cubed is 2. We're at the decimal. We move it 3 spots to the right because we're multiplying by 10 times 10 times 10. And there's our 2,000. So I'm going to say it's 400 times 2,000. We can pull out the calculator and say that would be 8,000,000, and that would be 800,000. And you know what? Let's write that as a decimal, as a scientific notation number. Here's our decimal. We have to move it 1, 2, 3, 4, 5. This would be 8 times 10 to the 5th power. And oh, by the way, that's the number that we got by multiplying the 4 times the 2 and multiplying the exponents as well in the decimal part. So there we go. We've got 4 times 10 squared times 2 times 10 cubed is 4 times 2. We kind of separate and conquer. Put the a's together, multiply them together. Put the 10 to the nth powers together and multiply them together, and we get an answer. So there's a pretty easy way to do it. Let's see. Let's do multiplication here and say, you know what? For this one, we got an a of 8, and our a fell between the 1 and the 10, and sure enough, works pretty well. What happens when we multiply the a's together and we don't quite get what a number that's between the 1 and 10? I've got some buttons here that are programmed for blue and for black and red and green, and sometimes they take me to different places. Alright, so sorry about that. Here's our 8.7, 2.5. The first step is multiply the number part of the two numbers. Multiply the a's. So here's my a, and I'd say, well, I say 8.7 times 2.5. And again, I would say if you wanted to, you could pause this, do it yourself, and then see what number we come up with, what I come up with in the video, and see if that's the same number that you get. The second step would be add the exponents. So I got 10 to the 4th power times 10 to the negative 12th power. We add the exponents. We get 10 to the 4 plus a negative 12 is 4 minus 12 is negative 8. So there's my answer, and I've got to take 8.7 times 2.5. So 8.7 times 2.5 gives me 21.75 times 10 to the negative 8th power. And that, if we stop there, we're not quite done, because remember, our a part has to be between 1 and 10. Could be equal to 1, but can't be equal to 10. And this number here is certainly greater than 10. So we kind of have to think about this and say, well, it's 21.75. Well, wait a second. That's not an a number. So I have to rewrite that as 2.175 times 10 to the 1st power, or 2.175 times 10 would give me 21.75. And then again, it's, well, we can group that as this. And then this would be 10 to the negative 8th power. And then we say, now we've got this 10 to the 1st power times 10 to the negative 8th power. We can add these because we've got the same base. So here would be our a, 2.175 times 10 to the negative 7th power. And that would be our answer, because that 2.175 is the correct a, or correct value for a, because that would fit into our definition for a. Times 10 to the negative 7th. Okay, well, that's our nth power, and we're okay with that. So there's our answer for that one. Let's go over here and just take a look at the same type of idea for this one here, and say, what is 4.25 times 10 to the 13th divided by 8.5 times 10 to the negative 2? Well, the same idea holds true. We can say that I'm going to divide these two numbers, and I'm going to group these two numbers as well. And I'm going to say 4.25 divided by 8.5. What is that? That we can pull out our calculators and say, well, that would be 0. Let's hang on a second. Let me make that blue. 0.5 times 10 to the 13 minus a negative 2, because we're dividing. 13 minus a negative 2 is 10 to the 15th power. So there's my 10 to the 15th power. And again, we're not quite done, because our a has to be between 1 and 10. Could be 1, can't be 10. And 0.5 is certainly less than 1. So we have to say that, well, you know what, now we've got to write this 0.5 in terms of scientific notation, we've got to say that it's 5 times 10 to the negative 1 power. We're going to group those together. Should have used blue. Sorry about that. Times 10 to the 15th power. And now we just simply take the 10 to the negative 1 power times 10 to the 15th power. We can group those together and say that now we can add those exponents. Our answer should be 5 times 10 to the 14th power, and we should be done. And that would be in scientific notation, because the a has to be between 1 and 10. That 5 is certainly between 1 and 10 times 10 to the 14th power, and there we're done. So again, if we get to some place, the tricky part is, I guess, if we get to something like this, 0.5 or 21.75, where we multiply the 8.7 times 2.5, that's not quite in scientific notation, so we've got to modify it to get down here. This one not in scientific notation, so we have to modify it to get right here. So right there and right there are our answers. All right, questions, bring them to class.